day everyone! Last time, we discussed the different concentrations of solutions. Today, we will be discussing the stoichiometric analysis of solutions, which involve the use of balanced chemical equation and can be done through these general steps. First is to balance the chemical equation. Next is converting the mass of the given to the moles of the given, followed by the conversion of moles of the given to the moles of the unknown. We will be using the mole ratio from the balance equation. And lastly, the moles of the unknown to the mass of the unknown. In order to understand it better, let's have an example. Calculate the mass in grams of calcium nitrate, which has a chemical formula of CaNO32 that can be produced by reacting 136 ml of 4.0 molar of nitric acid HNO3 with excess calcium hydroxide CaOH2. First, we need to get the molar mass of the following chemical formulas. Let us start with the molar mass of calcium nitrate. Calcium nitrate is CaNO3 2. Calcium, we have 1. Nitrogen, we have 1. Nitrogen, we have 2. Oxygen, we have 6 times their masses in the periodic table. Calcium is 40. Nitrogen is 14. Oxygen is 16. Giving us a molar mass of 164 gram per mole. Next, the molar mass of calcium hydroxide, CaOH2, calcium 1, oxygen is 2, hydrogen is 2. From the periodic table, mass of calcium is 40, oxygen is 16, hydrogen is 1, which is equal to 40, 32, to 74 grams per mole. And the molar mass of nitric acid, HNO3. We have hydrogen, which is equal to 1, nitrogen 1, oxygen is 3 times their masses, which is equal to 1, 14, 48, a total of 63 gram per mole. Okay. So, molar mass of the different chemical equations are now solved. Now, let us now follow the different steps in stoichiometric calculation, which is number 1, to balance the chemical equation. So, our chemical equation, we will be basing the chemical equation here in our example. So, from the given, we have the reaction between the nitric acid, HNO3, added to the calcium hydroxide, CaOH2, which gives us calcium nitrate with the formula CaNO3 to addition of water. So first, we need to see if the following elements here in the reactant side is the same with the number of atoms here on the product side. So number of hydrogen here is 1 plus 3. We have here 2. So we need to put here 2 and here 2 in order to balance the number of hydrogen, which is 4. Next, calcium is 1, oxygen 6, 7, 8, 6, 7, 8. Okay. As you can see, the equation is now balanced, but we cannot yet proceed with our next step, which is the converting the mass of the given to the moles of the given, because we do not have the value for the mass and we do not have yet the value for the moles. We only have the given, which is the molarity of the given solution and then its volume. From these two given, we can calculate the number of moles of the given. So N, or the number of moles of HNO3, is equal to the molarity times the volume of the solution. Molarity, which is equal to 4.00 molar times 0.136 liters, which will now give us the number of moles of our given 0.544 mole. Now that we have our number of moles of given, we can now proceed with the number of moles of the given, converting it to the number of moles of the unknown. So what is our unknown? Is the calcium nitrate. So using this equation or this answer, 0.544 mole of HNO3 times, this is now our mole ratio, and we will be using the balance equation here on top, which is in every, we have here the subscript 2, in every 2 moles of HNO3, we have 1 mole of calcium nitrate. So 1 mole of CaNO3 2. From this, we can extend our equation by following the fourth rule, which is converting the moles of the unknown to the mass of the unknown simply by adding another conversion factor here. We will be using the 1 mole of CaNO3 2, that is equal to how many grams? We have 164 grams of CaNO3 2. This value is our molar mass, which is 164 gram per mole. 164 grams per 1 mole of CaNO3. So, next thing to do is to cancel all the same units. Mole, mole, mole. The only unit left is grams. So we can now solve for the mass of the unknown, or the mass of the calcium nitrate. 0.544 mole times 1 divided by 2 times 164 will give us an answer of 44.6 grams of CaNO3 2. So the number of mass of calcium nitrate that can be produced by the reaction of nitric acid and calcium hydroxide is 44.6 grams of calcium nitrate.